Okay. Solve this problem, then I will tell the answer. What would be the answer? Okay.
80.
80. Okay. Any other person? Hello.
Yes, sir. Yes,
Any
sir.
other got answer?
Yes, sir. Actually, option C would be the right one, in my opinion.
I'm not able to hear you.
Q3.
What are you saying?
Sir, Q3 would be 80, so therefore
Okay,
C
okay.
answer
Uh,
answer C would be.
okay. All other got 80? One minute. Any other who got 80? Raise hand. Okay. So quickly in 1 minute I will solve. Then we will proceed to next question. And next question quickly we have to do. So here vapor absorption refrigeration system, heat pump with three thermal reservoirs. 1 minute. Heat pump with three thermal reservoirs as shown in the figure. Refrigeration effect of 100 watt is required. So refrigeration effect would be at the lower temperature. Lower is this. So here 100 watt at 250 Kelvin, and when the heat source is available at 400 Kelvin, heat source is this one. Heat rejection occurs at 300 Kelvin. So minimum value of heat required. So two equations we can use here, like Q2 plus Q3 is equal to Q1, right?
Yes, sir.
Yes, sir.
And here minimum value it has asked to show mean. What this minimum value just shows means all process would be the reversible.
Yes, sir.
So for the reversible, cyclic integral of q by t should be 0 or what? Less than 0.
Less than
Equal,
equal to 0.
equal to 0, sir. For reversible
For
process.
reversible, we have to consider 0.
Yes.
So heat coming to the system would we have to take as positive q2 by 250, and this q3 is also heat coming to the system. This is our system, okay? So heat coming
Q3.
coming to the system q3 by 400 should be equal to q1 by 300. We can solve.
300.
Sir, why it is written as work, sir? Q3 is written as work in the diagram.
No, no. Here they have just shown as work. It is vapor absorption refrigeration system, na. So here in vapor absorption, what would be there? Some heat source is there that used to give heat also, na.
Okay, sir.
So here no, we in vapor absorption we use not to we usually not give work there, na. Getting?
Yes, sir. Yes, sir.
Mhm. Also we can do in other from this way. This is just what we can say from basics we have did, but here also if someone would have remembered the formula for this vapor absorption refrigeration system, and here minimum value means reversible process, right? So
Yes, sir.
COP of vapor absorption from here also we can get these two equations and we can solve now. We know the value of Q2 and just solve it and we can get. So, but in another way, we know the COP of vapor absorption refrigeration system. What is the formula?
TG by TE into TG minus TA upon TA minus TE.
So here this is evaporator and this is generator, right? And this is environment. So
Environment.
formula is like what? TE TG TO by TG. To remember formula, you just have to write. Remember the ego by go e. By this way, you can remember,
Ah,
right?
yes, sir.
So
Once you told that.
just put the temperatures and what would the COP? Anyone calculated this way? So TE would be 250
Mm.
and TG is 400 and this is 300 and here TG is 400. Two methods I am solving. Okay, first I solved here and second I am solving here. TG and TO would be 300 and it is 250. So
1.25.
so COP ideal, this COP will become VARS. It will become 1.25, right? So now this is the just refrigeration effect and this is our evaporator and this would be the refrigeration effect and this would go this way and this is our environment or condenser. So just a refrigerator, this is just forget, now forget 400. This is our simple refrigeration system and COP, we know the COP of system. So we have to just find the what work we have to do. So we know the refrigeration. So what is the COP? COP is the refrigeration effect by energy input.
So Q2 by Q3.
So here would be the
Yes, sir.
Q2 by Q3. So COP we know, Q2 we know, and Q3 we can easily find here 100 by 1.25. 1.25 we can write as 5 by 4. So also 20, 80 here it will come. It is in the watt. So watt. So two methods. If you remember formula, then it's a very easy. If you don't know formula, then go by the basics. Okay. So any doubt here?
No,
Okay. Now do this problem. Here just in this problem you need not to solve whole. Okay, if your basics is clear, this for this problem I am saying just go for with basics and you can easily see what would be the answer. Oh, only 1 minute I will wait and tell.
see, sir.
Okay, and see anyone is getting any other answer?
No, no, sir. I am also getting free.
Okay,
Minus
can you
14.5.
tell how you did
Yes,
quickly?
sir.
uh, how hello.
Hello, sir.
How you got the answer?
Yes, sir. from dew point temperature to saturation temperature
Hmm. What happens there?
equal. At first, phi निकली तो P by T S.
Your voice is breaking in between. So any other person who did can tell how you solve? Hmm?
Hello, sir. Now I am audible, sir.
Now audible. Can you tell?
Yes, sir. As per it has been mentioned that relative humidity is 5%.
Okay.
So, so from here we can get the value of PV.
Okay. So PV would be what?
0.11.
0.1 into
0.116.
PVS. So
Yes,
And
sir.
since the water has condensed,
Uh-huh.
a layer of water is formed. So the temperature where the saturation pressure is this will be the water temperature.
what you said?
Since a thin layer of water is formed on the field, so this will be the saturation pressure of the water at that time. मतलब जो
Actually,
temperature हम find out
मतलब
करें.
सर ड्यू पॉइंट टेम्परेचर सैचुरेशन बार करना है, निकलना है.
Okay. So here you just find the PV. PV would be how much you are getting? 5 would be point zero zero
0.0.117 किलो पास्कल.
and 0.117 kPa. So this would be your PV. Hmm.
यस सर.
Okay. So you don't want what you don't want. Like hmm. When heat transfer will take place, how heat transfer here comes in that I want to know. How heat transfer will not happen.
Sir, didn't get
Here it is written neglecting
that.
the heat transfer between water and the ground, water temperature in the field after phase equilibrium. What is the meaning of phase equilibrium here?
Sir, it means that the relative
Phase
humidity is
equilibrium
not,
means,
One by one you can try.
since heat is not being transferred from the ground to the water, so relative humidity will be 5% only, sir.
Hmm. But here if you answer whatever you answer, you have told at that time what would be the relative humidity?
5%.
It would be 5%.
no sir, how could it be 5%?
That's why it would be 1 at that time, right? At this temperature, you said at this temperature, okay, equilibrium temperature. Hmm. So this temperature you said, and this is the PV. So 5 would be 1 at that time, right?
हाँ sir. Okay sir, जी sir.
Hmm.
तो सर 1 और 0 सर.
Huh?
सर 1 और 0 होगा फेज इक्विलिब्रियम में.
Phase equilibrium means just
ये process.
it is in the like it can just change the phase at that time. So means after this
हाँ सर.
whatever temperature just drops, then if temperature will drop, then what will happen? Just it will get condensed, right?
Relatively.
Condense.
Yes
If
sir,
it would
then
be more, then it is just not saturation would not be there. It is more than saturation. So it is just a boundary. So for this vapor pressure, we have to find the temperature. And this we can see here 0.117 it came, so it is close to this, so that's why minus 14.5 we have said. Also interpolation you can also do between these two, so that way also we can get. So here just means like what would be the pressure we are getting, so not here, not there. At that point we have to tell. एक मिनट. हेलो. अरे सेशन है अभी करते कॉल. ओके. So okay. Okay, yeah, this question, solve this question quickly. This is the first we will solving this refrigerator or normal refrigerator problems. Okay, in between also means here I mixed all the problems which we haven't solved yet for the previous years, and all the problems I have placed it today. So quickly we will do. So first tell what is the COP of Carnot refrigerator?
6.7
No, no. What is the formula? First is the formula.
TL by TH minus TL.
Lower temperature y higher minus lower. So here we have to find the reverse Carnot cycle maintained at this temperature, and ambient is this heat gained by the refrigerator at a continuous rate of this. So what is this rate heat?
मतलब इतना ही हीट वो लूज भी करेगा, मतलब लूज करना पड़ेगा इवेपोरेटर के थ्रू 2.5 किलो जूल पर सेकेंड.
So this is evaporator or condenser that I am saying asking.
इवेपोरेटर सर.
So refrigeration effect we can say, right? Hello, this is refrigeration effect or not?
Yes sir.
So we can simply find the COP from here. Lower temperature we know -5 and higher we know 35, and put this in the Kelvin only. Okay, so something you will get. How much you are getting?
373 watt.
No, no, COP is what?
6.7.
6.7. So see, when you will get the COP, so you have to now find the power because you know the refrigeration effect. So COP is the
Desired effect, refrigeration effect upon work input.
WIP. So we can find the WIP to the 2.5 by 6.7. So you have to write in the watt. Here it will come in kilowatts. So into 1000, whatever will come, it will be the answer. Okay.
Okay.
If I will go quickly, if any doubt would be there, just interrupt me. Okay. I don't think here any doubt would be there.
सर आरएससी के जो क्वेश्चन होते
हाँ. हेलो. हेलो. Am I audible?
yes sir.
Okay. Solve this problem. Here, industrial heat pump operates between these two temperature limit, and the rate of heat addition and the heat rejection is this and this COP of heat pump. Here it is 260 and it would be 300. This is heat pump. Some work input would be there. Uh, it is 750. It is 1000. Okay. So what would be the answer for this? Hello.
3, sir. Solving, sir.
Okay.
Option D.
Okay. Someone got 3.
सर 4 आ रहा है सर.
Okay. Someone got 4. How you got 3? Can you tell?
Sir, I am also getting 4, sir.
So what would be the COP for the heat pump? First, what would be the
Q1.
desired effect for the heat pump? What is the desired effect?
1000.
1000 means at higher temperature, whatever heat we are rejecting. So that would be our
1000
desired
by
effect. So here at lower temperature, we know we have to remove this much energy. So whatever energy work input we are giving, this minus this. So work input would be the 250.
Yes, sir.
So COP would be desired effect by energy input. Desired effect is 1000, energy input 250, right? So 4 would be the
Yes.
correct answer. 3 would not be there. Okay.
Sir, can you tell the difference between overall efficiency, first law efficiency, and second law efficiency?
What? Overall efficiency?
First law efficiency and second law efficiency.
Hmm, first law. 1 minute. I am forgetting it. Hmm.
Second law efficiency means comparing with the
Like
Carnot
cannot
efficiency.
like with actually what we are getting and what is the maximum possible. Uh, this is which one? Relative or
Second law efficiency.
hmm. Okay. So this problem here we have to find the specific uh, humidity. Here, do you need to change this vapor pressure or overall pressure to
No,
kilopascal
sir.
or not?
No, not needed.
Uh,
17.
any other getting the same answer?
No, sir, doing.
Anyone getting same answer? Here, what formula are you using? 0.622
Yes, sir.
PV by PT minus PV.
PT minus PV. So 0.622
17.04.
mm, 730. So whatever would be coming, multiply with that by 1000 because here we want in grams.
सर ये आरएसी में क्वेश्चन इतना बड़ा देता है और कंफ्यूजन में लगा देता है.
In RAC, always easy questions would be there and forget at least. So
ये क्वेश्चन थोड़ा बहुत बड़ा होता है और कंफ्यूजन में लगा देता है.
mm, here also same thing we have to do. Here in PV they haven't given but relative humidity given and saturation pressure given. So easily we can find the PV, right? PV would be 5 of PVS and we can get the uh, specific humidity omega 0.622 PV by PT minus PV. So no need to do this because same problem is this, right? So here PT is also given 100 and phi is given zero point 0.6. So same problem we have did lot of times. So whatever repetition would be there that we won't be doing, and new type of problem any new problem would be there that we will be doing. So what would you answer about this? Here what they are doing? If a mass of moist air contained in a closed metallic vessel is heated, then what will happen?
रिलेटिव ह्यूमिडिटी डिक्रीज करेगी सर.
Any other person? Any other person? What you are thinking?
Specific humidity increases.
Specific humidity. Relative humidity increases or decreases?
Sir, decreases, sir.
Initially you said increases, right?
Will
Hello. Hello.
Hello, sir. Yeah, am I audible, sir?
My network is fine or what? I'm not
sir,
getting
Yeah,
you.
your network is fine, but I am facing bit problem on my network.
Okay, okay. Okay,
sir,
so we can see like here what is happening if a mass of moist air contained in a closed metallic vessel is heated. So what is happening here? We are not adding any water content now. Okay, so is if water is not added, then what will happen? Omega would be the same or different.
Would
omega
be
will be same, sir.
Omega will be same. So now what is happening? It is getting heated. So this is our cyclometric chart. So let's suppose this is our initial condition, but omega would be the same. And now we are heating means temperature is increasing. Temperature will increase this way. So if this is same, now you are going to here, let's suppose. So what is happening with relative humidity? Increasing or decreasing?
Decreases.
decreasing.
Relative humidity will decrease. Specific humidity will remain constant, so these two would not be there.
Because of the heated in the closed container.
So it is closed container, so no water vapor addition or rejection. So do this problem quickly. I will wait for 2 minutes, then we'll start. Just two. Whoever getting answer, let me know.
So for the first problem, it would be 28.3
A, okay. Second.
A. Doing so.
So here refrigerator operates between this and this. Ideal vapor compressor cycle. Refrigerator enters compressor as a saturated vapor. Uh,
Power required is 39.5.
mm. Anyone getting the same?
Yes.
Okay. So I will. Everybody solved or someone not able to solve? So I will give hint. You can try.
No,
Everyone
sir.
solved.
Don't. Yes, I have solved that.
Sorry, sir. 7.9 होगा वो.
So
One
seven
point
point nine or 39.5.
7.9, sir.
Okay. Here
First
we will
one.
do quickly. You just tell the value. So here they have given refrigerant enters the compressor as a saturated vapor. Enters the compressor means here saturated vapor. Here it will come Now here, sorry, two divided 5, 1, 2, 3, 4. So for one, we know the data. So HF they have given. So what is HS? Heat enthalpy of steam. Okay. So we know H1 237 and S1 we know 0.95. So S2 also we know. What would be S2?
S1 would be the S2.
Okay.
As
So
as this as this is superheated vapor.
so what is the T2 you have got from here? How you find the T2?
Sir, CP not given, so not able to find T2.
CP, why CP not given here? Oh, CP not given, huh?
So डायरेक्टली जो 40 डिग्री सेल्सियस वाला वही डाटा यूज कर ले.
So only you used only this data, huh? No,
सर
no.
40 सेल्सियस वाला.
CP is not given because they have directly given the value of that. No? So how you used this same value? Can anyone tell?
Since 0.95 is the
Because
entropy.
S2 here entropy is given the same. So means this only we are looking for, right? If it would not be given, then we are looking for CP and then will be S2 minus this uh, SG. S2 minus SG would be the CP ln T2 by this temperature, saturation temperature. So from there we will be finding. But here they have directly given the properties. So we will take this. H2 would be the 276.45 and H3 already given in the problem. What is the H3? This 95.5.
95.5. H3 and H4 are the same.
So now and mass flow rate they have given 0.2 kilogram per second. Now you can find anything from here, right? So the rate at which heat is extracted in kilojoule per second means in kilowatt. We can first we can do 0.2 into
237 minus 95.5.
237 minus 95.5. So whatever will come, that would be the answer here. And for the second, power required in compressor what 0.2
Yes, sir.
and
7.9.
minus H1, right? So whatever will come, that would be the answer here. So that is also easy. So we can see. Uh, what would be the answer for this? Just quickly take 1 minute and tell. Nothing to do here. Anyone got anything?
25.
Any other person
Yes,
got?
yes, sir.
Hmm. So, what is the concept here?
Sir, wet bulb depression. At first, we have to calculate
Okay, what is the double weight bulb depression at 1?
20 degree, 20 degree centigrade.
Bulb depression is dVt minus WBT, right?
Yes, sir.
Okay, this is dVt 1 minus WBT 1. It
The
would be
concept of WBT will be same.
what?
WBT at inlet and exit will be same. The main
Yes,
concept.
sir.
So here what is happening? We are just adding the water vapor because it is humidifying with the air washer. So I told there because it is just simply that air saturation constant isenthalpic process. So same thing will happen. So wet bulb temperature would be for 1 and 2 would be the same. The main thing. And here they have what they have given the wet bulb depression at the
Is
inlet is
25%
25% of the inlet.
of inlet.
So
Yes, sir.
initially is 20. So what will be the 25% of this?
WBD inlet.
So wet bulb depression.
Outlet equal to 25% of WBD inlet.
So it would be only 5. So
Yes.
because the wet bulb temperature would be the same, so dVt of 2 would be the 5 plus 20,
Yes, sir.
25. So same problem we have did already also, but it was different problem, right?
Yes, sir. Yes, sir.
So you have to remember like here WBT would be the same.
बट सर एग्जाम हॉल में थोड़ा गड़बड़ाहट करेंगे तो हाँ,
It will with time it will happen. No. With practice it will go. No, nothing to worry. So what would be the answer for this? Here also you have to find the omega. If we are able to solve, we will read the question. If we same question we have solved, then we will leave. Sample of moist air at total pressure given, and the DVT temperature is 30 and saturation vapor pressure is 4.24. Here relative humidity they have given. So we can easily find the PV because PVS we know and relative humidity we know. So again the same type of problem, right? Right or not?
Yes, sir. The same.
So here also in grams, like similar problem. Here PV will find from here and omega is a 0.622 PV by PT minus PV. So find PV from here, put here, and PT is this. Put PT from here, and you can easily get and multiply this omega by 1000. Whatever will come, that would be the answer. Got it or not?
Yes, sir. 20.8.
So something will come 20.8. Whole thing
20.8. Yes, sir.
uh, gram per kg of dry air. So actually, I am rushing through because we have lot of questions. So whatever similar
Yes,
type of
sir.
problem would be coming, so that will go quickly, right?
हम्म, हम्म,
सर थोड़े बड़े क्वेश्चन करते हैं.
In GATE actually in RAC nothing will come bigger question. So that's why in classes I have taken a conventional problem that time.
ओके.
Today last class is there, so that's why I thought only GATE problems will take. So that's why you may like consider which type of problem is there in the GATE. So in GATEs only they used to give which you can solve in 1 or 2 minutes only.
sir, if I don't get desired problem, then I might uh,
Huh?
contact with you. Actually, if I don't get desired score in my get, then I might contact with you regarding any kind of problem I
Okay.
face.
So try this problem. here what they are doing in VC VCRS cycle it is. So in the evaporating and condensing temperature they have given. Compressor takes here come in compressor here this mixture is there.
Hmm.
So the specific heat of the liquid refrigerant is 4.8 and mate retail constant enthalpy of evaporation for the refrigerant is at, anyone did this?
Yes, sir.
Following
How much you are getting?
1103.2.
1000
1103.28.
1103.28. Okay, anyone getting the same? So only you have did, any other person did?
not getting
Okay. So what is this value?
H2 minus H3.
Hmm. H2 minus H3 and H2 minus H3 is 1054. So this is 1, 2, 3 and 4. H4 is
H3.
H3. Okay. So here,
Calculating COP,
huh?
H1 is by calculating COP, H2 minus H1 is 170.
So, sir, one thing.
Mm-hmm.
H2 minus H1.
How you got the COP?
TL by TH minus TL.
How you can consider this as a cannot? Is it cannot?
Okay, sir. Sorry, sir.
Second person, how you did this?
So actually, I at first find out the enthalpy differences as first one is the constant temperature means isothermal process, and process 1 to 2 would be the isentropic process.
No, no. How you got this 1103? From step by step, can you tell?
Yes, sir.
Tell. Start now.
First H1 equal to S2, assume,
Mm-hmm.
then H1 minus H0 by 260
Okay.
equal to S2 minus S0.
अरे ऐसे थोड़ी होगा भाई.
So why you are doing this? You are considering H2 and H1 as same, huh?
Yes, sir.
Why? How you are
No, no,
considering?
H2, no, no, H2 and H1 are not same, sir.
H2 you said or H2 you said? I'm not able to hear properly actually.
S2 minus S3 equal to H2 minus H1 by TC.
That would be the same, yeah. That is the entropy you can get from there, right?
Yes, sir.
Okay, then what you did with that?
Then S3 minus S naught equal to CPLN T3 minus T naught. Process 3 to 0 is equal
What
to
you said? What you said? Once again, you can repeat.
S3 minus S0 equal to CPLN T3 by T0.
CPLN.
T3 by T0.
Okay. So what you will get from there?
4.24.
No, no. What means what value you got? You are saying like you will get this value, huh?
Uh-huh.
Okay. Any other way? Can you think? Just think 1 more minute because it is a good question. Huh? So here you have to think. Otherwise, you can solve easily.
These kind of problems making actually confusion in exam.
Hmm.
What to do, what not to do. And so
Actually, here, what do
sometimes
you think? Which data is missing? Can you think? Or some data is missing, or everything is given?
अब लग रहा है सर एवरीथिंग इज गिवन.
Everything is given, right? Or not given?
सर आप तो बड़ी कंफ्यूजन में डाल दिए.
Just think. Other problems you can solve easily. Here only you will stop.
आरएससी में रट्टा मारना पड़ेगा सर.
रट्टा से कुछ नहीं होगा.
सर मेरा 1294 आ रहा है आंसर.
1294 गलत है. और सोचो कैसे आया 1294?
सीपी डेल्टा टी की है सर.
डेल्टा टी इज व्हाट?
अ, ये 310 माइनस 260.
क्या होगा? विच एच इज दिस? हम्म.
कर रहा था S2 माइनस S0, फिर उसको 260 से मल्टीप्लाई करके हो जाएगा, ऐसा लग रहा है.
ये जो पहले किया है ना वो थोड़ा सही वे है कि इधर से ये फाइंड कर लो और फिर उसमें ये डेल्टा एस इधर से मिलेगा. ठीक है. टेम्परेचर यू नो द टेम्परेचर ऑफ दिस राइट.
यस सर.
सो
सर ये डेल्टा एस कैसे फाइंड आउट करेंगे?
वही तो उसने किया है ना. इधर से स्टार्ट में बोला था जो डेल्टा एच.
एंथैल्पी डिफरेंस पहले फाइंड करना पड़ेगा. S1
हम्म.
माइनस S नॉट.
Okay, step by step we'll do. Huh? So we'll start from zero. Okay. So whatever data is given, accordingly we'll go and let's see what will happen. So first of all, it is given H2 minus H3, right? So here we can get easily S2 minus S3, right? What would be this? 1054 divided by 310. So what? How much this will? Can anyone tell?
3.4.
3.4. Okay. And so entropy difference. What would you like entropy difference from 1 to 0? H1 minus
H0 by T saturation.
how much temperature is 260, right? And we have to find this, right? This is our aim, correct? Or
Yes sir.
यस सर.
Yes sir.
and like here from here we can know S1 is same as S2, right?
S2. Yes sir.
S1 is equal to S2. So here we can write S2.
S2 minus S0.
Same thing, right?
Yes sir.
So next, anyhow, like we can get this value of S naught, or with we know this, right?
Yes sir.
So then we can just simplify, multiply this, and we can get this value. So this way we have to proceed. So now we know the from here to here. Let's suppose not much because here in liquid we generally with pressure we don't consider any change. Okay. So here whatever entropy will change that will due to the only temperature.
Temperature.
Correct?
Yes.
Is it correct or not?
Yes sir. Yes sir.
Yes, sir.
So so because here it is the third point. Now come straight because we want entropy here. and this is the 0 point. So what would the entropy difference between S3 minus S0?
CPLN T3 minus T0.
Cp ln because
T3
here
by
we
T0.
only know the temperature, right? We know the we also don't know the what is the pressure, and we with in the liquid pressure doesn't play any role. We know because it is incompressible in nature. So we neglect that part. T3 by T0. We know the T0, we know the T3, and we know the this Cp value. So how much
Yes, sir.
value we are getting from here?
0.8442.
Point
8442.
8442. So now let's suppose here it is S2 minus S3. This value you know, and here this is S3 minus S0. Right? This value you know. Now simply add these both equations, this and
Both
this.
the hmm.
Right? So when you add this, then S3 will cancel out, S2 minus S0 will come. So this is our aim only to find, right? So how much this is come? This will come. Add this and this. 3.4 plus 0.8442. Hello?
Yes, sir. Yes, sir. 4.2.
4.2442,
24.
right?
Hmm.
So now you know the S2 minus S0. Just simply you have to multiply this with 260.
Hmm.
S2 minus S0 into
Then
260. So how much it will come?
103.28 kilojoule per kg.
103.28. So here you have to find this because from above given value you can find only this much entropy difference, but here this much is left. So but here liquid is both conditions are liquid only, so we can find this. And here Cp with generally Cp will change with pressure, but here it is considered as constant. It is already given, so we can put that. Okay.
Hmm.
Okay. So this also you can do. Here standard VCRS cycle operating with a condensing temperature of 35 and the evaporating temperature minus 10 degrees Celsius develops 15 kilowatt of cooling. Mean this cooling this has been given. So it is 15 kilowatt. The pH diagram shows the enthalpy at various stages. If the isentropic efficiency of compressor is 0.75, it is given. The magnitude of the compressor power. So what would be the value? With this 15, what you will get, what you will get from here? Hello. What will be the refrigeration effect here?
15 kilowatts, sir.
No, no. This is a refrigeration capacity. Like whatever in the kilowatt would be there, that is refrigeration capacity. And the refrigeration, sorry, opposite I told. No? Refrigeration, this is refrigeration effect
Sir,
per
यहाँ से
kilojoule
mass
per
flow
kilogram would be that is refrigeration effect, and this is refrigeration capacity. With this mass, from here you can calculate the mass flow rate actually.
rate. Yes, sir.
So
Mass
refrigeration
flow rate.
effect would be the 150 kilojoule per kg, and this refrigeration capacity is given 15 kilowatt. So m dot we can find, m dot would be this refrigeration capacity divided by refrigeration effect. 400 minus 250 is 150. So this is 150. So
0.
150. So 0.
0.
Kilogram
Kilo.
per second. Right. Mass flow rate we can calculate from here. So this pH diagram is actually like mm, this is reversible. Okay. For the reversible cycle it is.
Sir, is the answer 10?
Mm, yes, yes, 10 is this. That's fine. So here this part shows the compressor work. So how much compressor work from will come from here? 75, right? 475 minus 400 would be 70, 470, sorry, 75. And efficiency is given as 0.75. Why we have divided here by efficiency, not multiplied?
Because it is a work absorbing.
Because here we have to give work. Whenever we have to give work, we have to divide it, and whenever we are getting from any direct work producing device, so there we will multiply. So how much it will come? 100 it will come, right? So m dot we know, this would be the kilojoule per kg. Now m dot is zero point 0.1, so w dot c would be the m dot into wc. Now it will become 10 kilowatt.
Sir, I did a mistake, sir. 5.625 ऐसा कुछ आ रहा है.
How? Why?
Yes, sir. That's point you told that what
Here only
you should do.
WC would be like this only,
Actually,
400, and you have
actually, I no. Actually, I multiplied 0.75 into 0.1.
why?
That's mistake I did, sir.
Mass flow rate, why you multiplied with that?
Yes, sir. Yes, sir.
Okay.
Compressor
Sir,
power.
work, work supplied mass flow rate into H2 minus H1.
Yes, yes.
We know the all values, the mass
No,
flow
no,
rate
no.
and H2.
This values are for the reversible cycle, but it is not reversible, so isentropic efficiency they have given. Okay. So this is for the this cycle holds good for the if compression would be this way. 1 minute. I will TS diagram I will show. This cycle, whatever this diagram is, na, it is for this type of system.
सर एक बार फिर से रिप्लाई कर दीजिए क्यों मल्टीप्लाई नहीं करना चाहिए क्यों
Four. So here whatever this diagram is, here we have isentropically compressed the air. So for that this is. But here they have given the isentropic efficiency of compressor. Now compression would be in which way? This way, right? So you have to
Okay,
find
okay,
this
okay,
2
okay.
dash.
Okay, okay, sir.
So for that, so here we can see for this work of compression would be h1, sorry, h2 minus h1, and for this would be h2 dash minus h1. So h2 dash would be more, or h2 would be more?
H2 dash.
H2 dash would be more, right? So here in compression you have to provide work. So what would be the efficiency of compressor? Isentropic efficiency.
H2 dash by H2 minus H1.
Isentropic efficiency of compressor means ideally how much work you have to give. Ideally how much you have to give? H2 by H1.
H2 minus H1.
And practically how much you are giving? H2 dash by H1. So in order to, what is this? This is the ideal work, right? W ideal. And what is this? This is W actual. And here what is given to you? Ideal or actual?
ideal.
So ideal is given. In order to find actual, what do you do? Ideal by efficiency of compressor, right? Getting or not getting?
हाँ got it.
So this is also the same problem. Relative humidity is given. So total pressure is this and saturation pressure is this. So you can easily find the omega, right? Right or not?
Yes.
Okay. So this problem you do quickly. Here what we have to do, I will give just a hint and then you solve. Partial pressure of water vapor or in moist air sample of relative humidity 70% is 1.6 kilopascal. So here PV is given, right? PV, this is PV, right? Partial vapor pressure of water vapor in moist air. Here this is phi and PV is given. Phi is given, PV is given. The total pressure and PT is also given. Moist air may be treated as an ideal gas mixture of water vapor and dry air. The relation between saturation temperature Ts and the saturation pressure Ps for the water is given by this. Okay, so in this equation you have to use Ps, but you have not been given Ps. Okay, how you will Ps using
फाइव से निकाल लूंगा. फाइव
1.6
इक्वल टू पी ओमेगा
0.6.
बाई पी है.
PV divided by pi, right? Is it correct? So you will get something PVS from here or PS, and P naught is the total pressure. Okay, P naught is given in the problem. PS you can find because we know the PV. PV is 1.6 and divided by zero point 0.7. Whatever will come, that will be this. And this all you know. You have to find the dry bulb temperature, means saturation temperature at that point you have to find. So we can simply put in this equation and we can get the TS, right? Getting or not getting?
हाँ सर.
Yes, sir.
So just tell value, what is the value of TS?
Nineteen point 89, 19.9.
In degrees Celsius, right?
Yes, sir.
19 point.
9.
Anyone getting the same?
Yes sir, almost 90.
So here nothing to like. This is new type of problem, but they have given everything, right? So
Mm-hmm.
here you have to just with the help of PV and the phi. What RAC they will try to check just relationship, simple relationship you know or not. They are just in that they are mingling, and here just a random formula they have given. From there you have to find the TS, right? Okay, so I think this we have did. So here relative humidity decreases. Okay, do this problem. I think this is the last. No? Okay, a heat engine having efficiency of 70% to drive a refrigerator having COP of 5. The energy absorbed from low temperature reservoir by the refrigerator for each kilojoule of energy absorbed from high temperature of source. Like how this diagram would be looking like. Let's suppose this is engine and this is refrigerator. Okay, so engine will produce work first. Here it is the higher temperature, this is the lower temperature, and this is the lower temperature, this is the higher temperature. So here heat will flow this way and here it will flow this way. Getting or not getting?
Yes, sir.
So heat
सर
engine.
सर सर
Yes.
एक बार फिर से ये डायग्राम बता दीजिए सर.
In engine what happens? Higher to lower heat flow would be there, right? And some heat work, some work it will produce this W, and this work is used to run the refrigerator, and refrigerator will
हाँ.
take free heat from the lower temperature to higher temperature. So they have given the efficiency of this engine as 0. 0.7 and COP of this refrigerator as 5. Hmm. The energy absorbed from the low temperature reservoir by the refrigerator, here this Q, for each kilojoule of energy absorbed from high temperature source by heat engine. Means here if 1 kilojoule of heat is absorbed, then how much of heat from this lower temperature would be removed? Getting or not getting the problem? Again I will read.
सर इसकी कोई यूनिट थोड़ी होगी.
Huh?
सर ये जो क्वांटिटी हम फाइंड आउट कर रहे हैं इसका तो यूनिट होगा नहीं.
क्यों?
क्यों केजी किलो जूल बाय किलो जूल है ना. तो
Why? Here why you are saying this? The energy I will tell. Huh? So energy absorbed from the low temperature reservoir by the refrigerator, this, huh? For each kilojoule of energy absorbed from the high temperature source by the engine, this is 1 kilojoule, efficiency is 0.7, so how much work it will produce? 0.7 only, right?
सर इज द आंसर 5.
Uh, and COP is 5 here. So what is the COP of refrigerator? Refrigeration effect by W input, and W input is
W
0.7 and COP is 5, so
into
refrigeration.
5 equal to 3.5.
सर इज द आंसर सी.
1 minute, हाँ,
Yes, yes.
Yes, sir.
so it will become 3.5. And why
3.5.
unit would be there? Because here whatever unit of this, same unit you will take, right? Why unit won't be there?
या सर यूनिट विल बी देयर.
So, and what you are asking about that time, first law efficiency and second law efficiency, right? So
यस.
what is related with the first law?
कंजर्वेशन ऑफ एनर्जी.
Conservation of energy means there would be one system in which you are providing some input and you are getting some output, right? In first law, and whatever is remaining, that is given to the surrounding, like this way. There are no destruction of energy, nothing, right or not?
यस सर.
So in first law, you will be giving some Q and you will be getting some W, and whatever is remaining, that will stored as the U, right? Hello.
यस सर. यस सर.
So here nothing like cannot and anything. No cannot will come into the picture. Nothing. So here
सर सर मतलब मैंने एक क्वेश्चन सॉल्व किया, मतलब एक क्वेश्चन देखा था, तो उसमें था कि एक आप एक बार डायग्राम बनाइए. 1000 किलो जूल का हीट सोर्स है.
एक मिनट.
500 सॉरी 1000 केल्विन का हीट सोर्स है और 500 केल्विन का हीट सिंक है. 300 जूल ऑफ वर्क इज प्रोड्यूस्ड बाय टेकिंग 1000 जूल एनर्जी.
1000 and how much work? 300. Work is how much?
सेकंड लॉ एफिशिएंसी.
Work is how much? 300. Huh?
300.
Okay. So here what we have to find?
ओवरऑल एफिशिएंसी,
Uh-huh.
फर्स्ट लॉ एफिशिएंसी, सेकंड लॉ एफिशिएंसी.
Okay. So here like in first law efficiency, first law efficiency is nothing you have to deal with, only energy. Here you need not to worry like whether this system is possible or not. First thing is that. Like you can say whether this system is possible or not. How if a Clausius inequality won't be applicable, like
सर
size.
पर क्लास इनइक्वालिटी तो सेकंड लॉ का पार्ट है, फर्स्ट लॉ का तो पार्ट नहीं है.
So in first law efficiency, you need not to worry about that. Main thing is that, I think. You
So
have
first law efficiency will be 0.3, मतलब 30%.
हाँ हाँ
तो ओवरऑल एफिशिएंसी क्या होगी?
actually overall efficiency mainly come into the picture where 4 5 systems are working.
सर मतलब इसके जो आंसर दिए हुए थे वो थे एक्चुअल एफिशिएंसी है 0.3,
हम्म
फर्स्ट लॉ एफिशिएंसी है 0.5.
वो क्या नाम है वही वाला अपना करनॉट लग जाएगा सेकंड लॉ में।
सेकंड लॉ में सर 0.6 है, कार नोट वार नोट नहीं लग रहा है.
सेकंड लॉ कैसे है? अच्छा सेकंड लॉ तो वो कैन आइडियल बाई एंड कैरनॉट ये होगा ना जो
हाँ सर,
है
हाँ
अभी
सर. सेकंड लॉ
एक्चुअल बाई
आइडियल
कैरनॉट ये
बाय.
होगा उसमें हाँ सेकंड
हाँ
लॉ।
सर. पर सर फर्स्ट लॉ में कार नोट का एप्लीकेशन क्यों कर दिया 1 - TL/TJ?
फर्स्ट लॉ एफिशिएंसी में।
हाँ सर, मतलब कि 0.5 दी है फर्स्ट लॉ एफिशिएंसी.
ओके ओके फर्स्ट लॉ एफिशिएंसी व्हाट एवर एफिशिएंसी वी आर कैलकुलेटिंग एज ऑफ नाउ ना generally first law efficiency. So any efficiency like work output net work w net by energy input. Okay, so whatever efficiency will come by this way, so this is the first law efficiency. Hmm. And like here this is not ideal process, right? Ideally this would be how much if it would convert, this would be 500 then na?
यस सर.
Some irreversibility is there.
यस सर.
So second law, first law doesn't associate with irreversibility. Okay, here only energy conservation would be there in first law. So that's
ओके
why
सर.
ideal efficiency would be in the first law. So in second law efficiency formula is this: efficiency actual divided by efficiency ideal.
आइडियल मींस फर्स्ट लॉ.
Ideal means like auto cycle you are considering, huh? So in auto cycle or diesel cycle, whatever efficiency currently we are getting with formula, that is the ideal efficiency. Hmm. So and they will say like 50% of ideal is their real efficiency. So second law efficiency is 50%. If we say 50% of real, like in vapor absorption, we whatever formula we are using, that is the ideal efficiency, and it will say 0.15 of ideal. So then second law efficiency is 0.15. So actual means whatever system will deviate from reversibility, right? So how we will show generally that irreversibility we deal in second law. So that's why we said second law efficiency to that.
But sir, why first law efficiency for this problem is 0.5?
So actually this is cannot if you forget about this, okay, heat anything. Hmm. So now it will become cannot cycle.
Yes, sir.
Hmm. So in first law, we have to do the ideally they have found in first law.
But that is find out by second law. मतलब second law बताता है ना हमें वो सब चीजें तो.
नहीं, नहीं. तो here also the same thing. You forgot this whatever data is there given. Okay. So here what will happen? First law just gives the conversion from heat to work. It will convert will there, and second law gives the direction. Main aim is this only. And efficiency you haven't calculated here. Actually both will associate. So means there is no correlation between first law and first law efficiency that way, I will say. Uh,
हाँ.
efficiency will come into the picture after when you starting calculating the things, heat pump, refrigerator.
ओके सर. ओके.
Here only we will conversion we will saying heat to work, that way only. So first law
Yes,
efficiency we
in
can say
the
ideal, whatever efficiency we are going to calculate ideally, and second law Actually, what we are getting relative to what maximum we can get. Or
Okay,
first law we can say how much maximum capability to get how like here q would be there, right? So out of that q, how much work we have got, that will be told in the first law efficiency, and in the second law efficiency how much maximum efficiency was the possible, and what efficiency we have achieved. So second law efficiency is the relation between the efficiency only, and here in first law we are dealing with the energy, that also we can say.
okay, sir. Okay.
Mhm. Okay.
In this session, first problem VARS solved by the entropy principle.
No, both way we can solve that, because they are
Huh.
ideally we are going to do na, so that we can do. Sorry, this problem you are saying, right?
Yes, sir.
So here we can go this way also, and with the COP also we can do with the
How
COP
to?
formula, because we know the ideal COP formula. That COP formula we have derived this way only, right?
Oh, okay, okay.
Here if no if you forgot the formula, then we can go this way. Hmm.
Sir, what is the actual significance and meaning of the Gibbs function and the Helmholtz function?
Gives function gives function practically we use in the phase change processes actually. So what is the Gibbs function?
Enthalpy H minus Ts.
H minus Ts. And what is Helmholtz function?
Internal energy minus Ts.
U minus Ts. So for practical application use for Helmholtz function I'm not sure, but for Gibbs function when we write this dg, how what will become? Dh minus tds minus sdt. And what is dh? Du, sorry, uh, dh what we can write? H is equal to u plus pv, right? Du plus pdv plus vdp minus tds minus sdt, right? Right or not?
Yes, sir.
Du plus pdv will become dq, and dq will become tds. So this tds and this tds will cancel out, right?
Okay.
So dg will become what? um, vdp minus sdt, correct? Correct or not? Till here it is
Fine.
or not? You tell this. So what is happening here? dp, vdp and sdt in phase change, what is happening? Let's suppose this constant pressure. So they say temperature is constant and pressure. So here phase change is happening, right? This is P is equal to constant, and for the phase change temperature is also constant, right?
Both are constant.
So at the phase change, what will happen with dg? dp is 0, dt is 0, so dg will become 0, right?
Yes, sir.
So Gibbs function use is like for the phase change, any phase change like melting, alloy you are making, solidification, whatever is there. So dg is 0, and if dg is negative, then we used to say process is spontaneous. Process spontaneous means what is dg? Like let's suppose you are solidifying something. So initially it would be liquid, right? Liquid. So later what will become? Solid. It will become. Correct? Correct
Yes,
or
sir.
not? So first condition is this, second condition is this. So energy of the solid is less than the energy of liquid. It is correct or not?
Yes, sir.
So gives free energy of, let's suppose this is gives free energy G2 and this is G1. So dg is G2 minus G1. So it would be negative, right? Because second energy of second is less than the one, because it is solid, it is liquid. So that's why this solidification process is spontaneous. So here dg will become negative. If dg becomes negative, then means process is whatever solidification anything, then phase change will happen, because here a change in dg is there. So if dg is 0, means at that point phase change is happening, and dg is negative, process is spontaneous, and dg is more than 0, means this process will not happen automatically. We have to give some amount of work to this to happen this, right? So when solid is there, we have to melt it. Then what we are going to do, we give heat, right? Hello.
Yes, sir.
Huh.
Yes,
Oh, sorry. It is correct or not? So
yes, sir.
this is the use of Gibbs function. So with the Gibbs function, and also Gibbs and Helmont function we can use. um, I think that I have covered or not. In thermodynamics, I would have told. Uh, Sorry, no, there we can't use. So for this is the application of Gibbs function. Okay. So Helmont practical application, I cannot remember. So that I won't be telling. So Gibbs function, this is the practical application.
Sir, what is the endothermic reaction?
Endothermic means when any reaction is happening, and you have to, in order to happen that reaction, you have to provide energy to the system. Okay. So exothermic means when reaction will happen, energy will be coming out of the system. And let's suppose this is the system. So when reaction will happen and reaction is coming out, sorry, enthalpy or heat, or in order to make happen some reactions, you have to provide the heat. If you are giving the heat, then endothermic. If a heat is coming out of the system, then exothermic. Clear or not? Hello.
Yes, sir. Please.
Okay. Okay, sir. So if I, 1 minute. Okay, then so for today we would be closing. If any like doubt in between anything is there, you can contact me in WhatsApp.
Sir, van der Waal equation, questions asked from gate, if
No, no,
possible.
nothing will come in that perspective.
From van der Waal equation.
No, 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 no. Simple use they will ask. If a van der Waal equation, anything they will ask also, then they will provide you van der Waal equation, and all data they will give, and there some variation will happening, like pressure will change, so temperature you have to find. So they would be providing that. So there only you have to simple use they will give. Van der Waal equation will take time. So they will give the problem which can be solved in 2 3 minutes, because they are giving 3 minutes maximum for one problem.
Okay, sir.
Okay. So I will type my mail ID and the mobile number here. If any doubt will come, so you can contact me there.